Hello, student. Welcome to Permutation Combination Part 7. Here we'll study about the circular permutation. So, what is the difference between that? So, circular, suppose A, B, C, D is sitting in circular condition. And now you cut it here from here and make a table. You cut it better, you cut it from here and make a table. So, A, B, C, D is there. So A, B, C, D. Now you have shifted like this. D has come here, A has come here, B has come here, and C has come here. And you are cutting here. So A, B, C, D. This will become D, A, B, C. Now you shift again. Now D become here, A become here, B become here, C. We are cutting here. So this is C D A C D A B. Now again, if shift again, then here will be B C D E. We are cutting here, then A B B C B E. So in linear arrangement, all four are different. But in circular arrangement, all these are same. So if 4% are sitting, then we'll have to divide the by 4. That means factorial 4 divided by factorial divided by 4. So that will be, if n% are there, the n divided by n. So that will be factorial n minus 1. So in circular permutation, if n% are sitting together, the number of arrangement will be factorial n minus 1. Why? Why? Because if we rotate, then all the arrangement is considered 1. And if anti-clockwise also considered 1, then we'll have to divide further by 2. So if clockwise and anti-clockwise, that is also same, then we'll have to divide 2. If both are not considered same, then we did not divide by 2. So you have to understand from the problem whether it's a considering clockwise or anti-clockwise same or not. Now see this question: in how many ways a student can be arranged in a round table so that two particular students are together, seat are with respect to each other, and the seat are not numbered. Seat are not numbered. That means 1, 2, 3, 4 is not different from 4, 1, 3. These are same. So what we'll do? 6 student is there: S1, S2, S3, S4, S5, S6, S7, S7, S8. S8 student are there. So two S1 or S2 will be together only. So total entity will be 7, and 1 so factorial 7 divided by 7. And two students are together, but they can exchange their seat. That is S2, S1, this also can be there. So you have to multiply by 2 factorial. So that is factorial 6 into factorial. Factorial 6 into factorial 2 minus 2, that is into 50. And if the seats are numbered serially, So that way rotation formula will not do. So will be factorial 7, factorial 8. Factorial 7. Factorial 7, why is 7? Because uh, 6 is there and 2 will be always together. So 6 plus 1, 7. But here will not divide by 7. Why? Because seat are numbered. That means this position and this position are different. So it will be uh, done like a linear thing. Its seats are numbered. Factorial 7 and 2 factorial 2 because S1 and S2 exchange common here. That will be equal to, so this will not be there. So this will need to 1008. Now we'll be solving some few more questions of circular permutation. So here, how many 6 men and 3 women can seated in a round table so that every man has a women by his side? So for 3 men, first you arrange women. Then 6 men should be beside. So M1, M2, M3, M4, M5, M6. So women has factorial 2 position because it's a circular, and then if women is fixed, the man is having 6 positions. So 6. So that is equal to 1440. Now come to the next question. Find the number of each 12 different flowers and 4 are having the same. The 4 are same. 1, 2, 3, 4. And 12 different flowers are there. So this is remaining 8. So first you fix this one. So this one you fix in how many ways? One way. But it can arrange by itself by factorial theorem. So total 8 and plus this one 9. 9 minus 1. That is factorial 8. So that will be this many ways. But this is a garland, so if 4 in this direction and 4 in this direction, and that will maybe considered same. So divide by factorial, divide by 2. Now come to the question number 4. How many necklace of bara bead each can be made of 18? So first you select 12. So how you will select 12? So you select 18CR. So 18C 12. So what is 18C 12? Factorial 18 divided by factorial 12 into factorial 12 minus 18 minus 12. So this is 18CR. That you have selected this one. Now you have selected 12 bead. So 12 bead in a circular. So circular how many ways? 11 because 12 minus 1. So this one is factorial 18 to factorial 12 into factorial 6 into factorial 11. This bit cancel. This will be 12. So answer will be factorial 18 divided by 12 into factorial 6. Actually here we have used what? Arrangement. Arrangement is equal to selection plus rearrangement. So first we have selected 12. So selection is NCR. Arrangement is NPR. And rearrangement is you have selected R. So there will be factorial R. So this formula is very important. NCR into factorial. So this will be utilizing, then we will be reading, studying the combination. Combination means nothing but selection. For the time being, just to learn this. Three boys and three girls are around the table in a circle, among them X boy. Suppose here X boy is there, here Y girl is there, and here will be boy 1 and boy. Here girl 1 and girl. So X, Y that you have fixed. So Y or X both are same. So either this way or this way. This is called one way only. So this will be boy once X and Y is fixed, then B1, B2 by factorial 2 method. So that will be factorial 2, and this is also factorial 2, G2. So factorial 2. So factorial 2 is factorial 2 into factorial 2 is equal to factorial 4. So now come to the 6, question number 6. So six ladies and six gentlemen sit together. There is no restriction. If no restriction, then 6 plus 6 minus 1 is 11. That means factorial 11 is circular. And there is no restriction. And two ladies sit side by side. No two ladies. So first you fix gentlemen. So gentlemen, how many ways you can fix? Can fix is a factorial 5 ways, because 6 gentlemen. Then once gentleman is fixed, then for lady it's a 6th place. Then it is factorial 6. So answer is factorial 6 into factorial 5. Now come to the question number 7. Question number 7 is very interesting. Four married couples round a and spouses are sit opposite to each other. So suppose one husband is fixed, you are fixing here. So wife will be already fixed. So any husband wife combination means H1W1, H2W2, H3W3, H4W4. How many ways you can fix? You can fix only one way, because you fix here, here, here. It's a similar. So this here you have fixed. Once you have fixed this, then position is vacant. How many position? 1, 2, 3, 4, 5, and 6. 6 positions are vacant. So next combination can go to any 6 position. So then 6 is occupied. This is will go to any 4 positions, because 2 position more further 2 position is occupied. So left is this one on this one. You can say, but this one is already occupied. So this one is 4 position. So once this position gone, then only 2 position are left. So this will be occupied by 2 positions. So answer will be 6 into 4 into 2. And for the men and women are alternate. So men and women are alternate. That means first you fix men. So men, how many position? Total 3 position. Then for women, it is a 4 position. So men is a how many position? 4 position. So that means it is factorial. Second is very easy. First you must remember this type of questions. Now, in how many way 8 friends can sit around a table? No restriction. Factorial 7. 8 minus 1. A party has 20 participants, and find the number of ways for the host to sit with them around a circular table. How many of these ways have two specified person on either side of host? So first is no restriction. So host, suppose this one host and plus 20. So total 21. So how many ways? 20 ways. 21 minus 1, that is 20 ways. With no restriction. And how many ways? There are two specified person either by the host. this host is fixed, then here x1 and x2 particular person will sit together in how many ways? Factorial 2 ways. So how much balance? 18 seats are balance. So that will be factorial 18. Factorial 18. So this will be the factorial 18. Now come to the question number 3. Delegates from the 24 countries in a round table discussion. Find the number of sitting arrangements where two specified delegates are always together. So two are always together. So we consider it one entity, and this is 22. Then remaining are 22. So total are 23. So 23 will be 22. 23 minus 1. So 23 in circular, one you have to take, but x, y can sit together as x and y and x also. So this will be factorial. So for A, answer will be 2 into factorial. And B, never together. So never together, then you do one thing. 20, how many without restriction, how many can sit without restriction, they can sit in 23, factorial 23 ways. So minus 2 into factorial 22. Then this will be factorial 22, you take common. Then 23 minus 2. So that is 21 into factorial 22. With the now fourth number, find the number of 15 people sit together around the table so that no two arrangement have the same number. So that means, see, suppose uh, suppose 1 and 2 person is there. So this should not be there. That means if clockwise and anti-clockwise to be restricted. So this can be done by factorial 14, and to this one is will be considered 1 because this is not possible. So that is divided by 2. So answer will be factorial 14 by factorial 2. A committee of 10 members sit around a table. Find the number of arrangements that have president and the vice president together. So president and vice president are together. So this they can be city anywhere. So that is one way, but they themselves can exchange the places. So that will be factorial 2. So remaining is 8 members. So factorial 2 into factorial 8. Now come to the question number 6. 5 men, 2 women, and a child sit around a table. Find the number of arrangements where the child is seated between 2 women. So first you fix this child. This child is sitting here. So 2 women W1, W2 will be. So W1, W2 either they can sit here or sit here. Exchange the places like W2, W1. So this will be factorial 2. So how many places are there? So places are for the 5 men. So answer will be factorial 2 into factorial 5. And between the 2 men. So between the 2 men, how you can do that? So first you have to fix the men. So first you select the men, 2 men. So 2 men you can select 5C2 and men here and men 2 and child will sit here. So this will be 5C2 into factorial 2. because main here also and here also can sit M2 here and M1 here. So 5C2 into 2. 5C2 into factorial 2. And in between child will sit. So how many remain? 3 men and 2 women will be remain. 3 men and 2 women. So that is 4 place. They can sit anywhere. So factorial 5 into factorial 2 into factorial 5. So that is equal to 24. 5C2 5 into 4 divided by factorial 2. This is 120. And 120 into 20 24. Now come to the question number 7. 8 men and 6 women around the table. How many sitting arrangement will be? There is no 2 women together. So first 8 men, fix 8 men. So 8 men and 1 man, 2 and 3 and 4 and 5 and 6 and 7 men. So how many ways? Factorial 7 ways. Factorial 7. So how many places are there now? 8 places are there. 8 in 8 how many women has to sit? In 8 places 6 women. So 8p6. So this will be the answer. Now come to the question number 8. Find the number of sitting arrangement 3 men 3 women to sit around a table so that exactly 2 women are together. So 2 women are together. W1 double. How many ways? They can exchange their places. So this is factorial 2 way. So how many remaining are there? 4 are there. 3 men. Exactly 2 women are exactly 2 women are together. So here will be men are there. So 3 men, 2 places. 3 P and here remaining 3 women. How many women will be there? 2 men. So 2 men is gone. So how many men will be there? Men 1 man, W3 and W4 and M3. So 1 man and 1 women are there. So how many they can sit together? They can sit together by factorial. So actually here W1, W2 we are selecting. So how many W1 and W2 select? That is 3P2 games. First, you do one thing. 3C 2 base. 3C 2 base. So 2 you are selected and these 2 you can arrange in factorial 2 base. Okay. Now 2 place for men are fixed. So 3 men can be 3P2, 3P2 base. Now 1 man M3 and 1 woman W3 is balanced. How many ways this can factorial 2 base? So this you include that, then this is 3P2 into 3P2 into factorial. So this is the answer. Now come question number 10. 4 objects set in set of 10 objects are alike. 4s are alike. So 4 alike. Okay. Find the number of arranging them in circular. So total is 10. So factorial 9 divided by factorial 4 because 4 are alike. 9 by 9 because 10 minus 1 is 9. 10 minus 1 y because it's a circular. Now come to the question number 10. 15% sits around a table. Find the number of arrangement that have two specified person not sitting side by side. So without any restriction is factorial 14. Without any restriction is factorial 14. Yeah. And find the number of arrangement that two person specified not sitting side by side. Let two person sitting side by side. So minus factorial 13 into factorial 2. So this will be factorial 13 common 14 minus 2. So that is 12. 12 into factorial 13. 12 into factorial 13 will be the answer. Thank you.